Hello everyone, my name is Andran Ali, the Bazooka Prophet, and today we'll be working on a very interesting video talking about the calculation involved in empirical and molecular formula. Before we begin the calculation, we should understand some basic rudiments about it. That empirical formula is also called the simplest formula. It tells us the number of atoms present in each element of a compound in their simplest ratio, while molecular formula tells us the actual number of atoms present in each element of a compound. We may not really have enough time to go into details, but with the calculation we should understand. Now, in the calculation on empirical formula, we should understand that there are two things you should know. Firstly, bring out the elements that you were given, and secondly, calculate the relative number of moles of each of the atoms of the element present in the compound as we go. Now, the question here gives us, bring out, we have carbon, we have hydrogen, we have oxygen, and we're giving each of their composition by mass in percentage, which in percentage is 100 altogether. So it means it must be 100%, which is 100 grams. So here you'll be having here to be 40.92. Here hydrogen is 4.58, and oxygen is 54.50. You divide each of them by their relative atomic masses and you were given. For carbon, it was 12.01. For hydrogen, it was 1.008. And for oxygen, it was 16.00. Very simple. So next is when you divide, you'll be having their moles, their mole ratios. For carbon, when you divide these two, you'll be having 3.407. While here should give us 4.58. Last day should give me 3.406. Now what do you do next? You have to divide each of them. Take note, by the smallest mole ratio. When you divide all through by the smallest mole ratio. And if you look at what you have here, the smallest mole ratio here is that of oxygen, which is 3.406. So here by 3.406, here 3.406. Same with this. So when you divide, here will give me 1. Here will give me 1.34. Okay, if I'm not mistaken, yeah. While here should give me 1 still. Now, remember that we have said that empirical formula is the simplest ratio. That is a positive whole number. And then you are having decimal number here. And decimal number is not something that we can do away with. Take note. So if you are having something of this nature, which is 1.34, or not until you are having a whole number or something that is like from like 0.0 or 0.0 something, please do not approximate. If you are having one like 0.4, 0.2, 0.2.5, 0.2, please do not approximate. So you don't approximate anyhow here. So follow my rules. So here you are just having carbon, hydrogen, oxygen. Carbon here is 1, hydrogen here is 1.34, while here is also 1. Now you look for a whole number that you use to multiply this one with, that will give us a whole number or an integer. So here is 1.34. First of all, when you type it by meaning what we are using trial by error method here. 1.34 times 1 will give me same 1.34. I use 1.34 times 2. I should be having here to be 2.68. But if I'm not making use of 1.34 times 3, I'll be having here is 3 times 4. So I'll be having it to be 4.02. So this one can be approximated to be 4. So it means 3 is what we use to multiply all through to get a positive integer. So what do we do here? So here is carbon, hydrogen, and here is oxygen. So times by 3. So 3 times that of carbon here will give me C3. While here will give me 4. While here will give me O3. So this is the empirical formula for ascorbic acid. So now our next question now that we have to enter, we'll solve more questions. Okay. So in the next question, the question says, in one experiment, the combustion of 11.5 grams of alcohol produced 22 grams of carbon dioxide, which is CO2, and 13.5 grams of H2O. Question says, determine the empirical formula of the alcohol. Now, we should not forget that the components of alcohol are carbon, hydrogen, and also oxygen. Now, but we are going to do it based on the calculations here. If you look at this question, it is not like others that are like the previous one. We're not giving directly the carbon, so it means we have to calculate the carbon from CO2. We're not giving that of hydrogen. It means we are going to calculate the mass of hydrogen from H2O. Then we will then sum it up. If it's not up to the mass of alcohol given to us, it means that there is oxygen in it. So we'll get it. So let's do it together. Very simple. To get for the mass of carbon, so the mass of carbon here is the mass of the compound, which is CO2, which is 22 over the molar mass of CO2 when calculated gives us 44, as carbon is 12.01, oxygen 16 times 2, so here it becomes 44, multiplied by the mass or the molar mass of carbon in the compound there, and that will be 12.01. All together we will do it. So here we come as 22 over 44. That's very simple, times 12. So we should be having to be 6. Okay, 6 grams of carbon. Now that of the mass of hydrogen is also same. So what do we do? So it becomes the mass of water, which is 13.5 grams, over the molar mass of H2O, which is water, is 18 grams per mole, which is 18, times the molar mass of hydrogen in the compound. Hydrogen is 1.008 times 2. So here becomes, so times 2, here will give me as 2. So when you multiply, you divide, you are having it to be 1.51. Okay, let me make sure that what I'm doing here is accurate. As so that is 13.5 divided by 18 multiplied by 2 should give me, okay, that's 1.5 grams of hydrogen. Very simple. Now when you add the mass of the mass of hydrogen to that of carbon, you will find out that it is not up to 11.5. So what do we do now? Very simple. So it means that oxygen is inside. So here become the mass of oxygen is now equal to 11.5, which is the total mass of the alcohol, minus bracket 6 plus 1.5 all together. So here gives me 7.5. 11.5 minus 7.5. Here should give me 4 grams. So we come here to say carbon, hydrogen, and oxygen. The carbon here was given to me to be 6 grams, hydrogen 1.5, oxygen 4. We divide by their relative atomic masses. Carbon is 12.01, hydrogen is 1.008, and oxygen is 16. When you divide, here should give me 0.5. Here should give me 1.5. Here should give me 1.5 still. Right here should give me as 0.25. So we continue. Now, from the simple rules I gave to you, the simplest more ratio here is this. When I divide here by 0.25, divide here by 0.25, divide here by 0.25. Like here will give me 1, Here will give me 2. If I'm not mistaken, 0.5 divided by 0.25. Yeah, 2. Why here should give me, okay, 6. 1.5 divided by 0.25. Okay. So therefore, the empirical formula of this atoms here in the compound here become carbon here is 2, hydrogen here is 6, and oxygen here is 1. So that is the final answer. So we'll move to the last question that we're going to solve for this particular video. So in the last question, the question says, a sample of a compound contains 1.52 gram nitrogen and 3.47 gram of oxygen. The molar mass of the compound is 92 gram. Determine the molecular mass. Now, you should take note that the molecular formula should do us here. Now, we should know that before we can solve for the molecular formula, we should be able to know the molar mass of the compound to ease us. So, very simple. What do? We bring out what we're giving. We're giving nitrogen here, we're giving oxygen here. Now, the nitrogen here, the mass was 1.52, and that of oxygen was 3.47. The RM of nitrogen was 14.01, oxygen was 16. You divide here should give me 0.108, here should give me 0.217. So you divide both sides by the smallest ratio, which is 0.108, here to 0.108. Here will give me 1, while here will give me what now? 2. Okay, here should give me 2. Yeah, 2. So that the empirical formula here becomes NO2. NO2, that's for the empirical formula. Now that we have the empirical formula, we then move, so we're already aware that it is NO2. So let's move straight away in solving the molecular formula. The molecular formula. Now we should understand that there is a connectivity between the molecular formula and the empirical what? And the empirical formula, which is the ratio. And the ratio is simply N, as N is equal to the molar mass that was given to us in the question, which is 92 over the empirical molar mass. And to get it, is this NO2 here. So nitrogen here is already 14.01 plus oxygen here, which is that's 32. So altogether here will give me 46. That's 46. Yeah, 0.01. So here become 46.01. When you divide, it should give me 2. So therefore, we will now know that the molecular formula MF is equal to the empirical formula that you have, which is NO2 times the integer that you added. So therefore, molecular formula is equal to NO2 times M, which is 2. It will give me N2O4. That is the final answer to the question. Now that you fully understood the calculation involved here, what do we do next? This one is a very good question for you to try. So you will solve it. Then when you are done solving it, to put your answer and your procedure on the comment section on my YouTube channel, and I'll get back to you and upload it. The question says, if the composition of phosphorus and oxygen in an oxide of phosphorus contains 43.7% phosphorus and 56.3% oxygen by mass, determine the empirical formula. For now, say God bless you. Do well to subscribe to my YouTube channel and share this video to anyone who would like to see it. God bless you.